This recording is to help you with Lesson 5.01, Using Fundamental Identities. We're going to start off by finding the other trig values if we know what secant is and sine is. Well, secant is -1. And remember, secant is the same thing as 1 over cosine. So if we have -1 for secant, to find cosine, we need to take that reciprocal. And the reciprocal of -1 over 1 is 1 over -1. So cosine is still -1. All right, sine, we have 0 over 1, which is the same thing as 0, right? So to find cosecant, we take the reciprocal, and that's 1 over 0, and that we know is undefined. So cosecant down here is undefined. That leaves tangent and cotangent left. Well, tangent, remember, is sine over cosine, so that is 0 over -1, so that's just 0. And then cotangent is that reciprocal, which is -1 over 0, which is undefined, because you can't have 0 in the denominator of a fraction. Right, the next one is a little tricky because you're going to have to graph your two trig functions and look at this. All right, the first one says the tangent x graph. So I graphed what tangent x is, and I zoomed in here. And we want to know, what is your graph approaching as x goes to pi over 2? And pi over 2 is this first vertical asymptote that you see. So let's see what our graph is approaching as we get near that yellow line. Well, it keeps going up and 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 up, and it actually continues forever in that upward direction. So because it's continuing upward forever, we say that our graph is approaching infinity. Now, in cotangent graph, what is your line approaching as it gets closer to pi over 2? And that pi over 2 this time, I'm going to highlight it in yellow, is right there. And let's see, what is our graph approaching from the left? So on the left-hand side of that line, as I get closer and closer to the yellow line, my graph is getting closer and closer to 0. Notice how it's getting closer and closer to that x-axis here. So we say that the graph is approaching 0. Now this is a difficult concept to kind of grasp because, believe it or not, this is something we call limits. And it's actually a calculus topic. All right, from here on out, hopefully after today's class, and today meaning Tuesday, December 13th, this will make a little bit more sense because now we're going to be using the Pythagorean identities. So if you were in class, you've got that worksheet, or not worksheet, but that printout of all the identities that you can use to verify your problems here. So we're going to start by saying, what can we replace secant squared x minus 1 with? Well, using our Pythagorean identities, and you can find these listed in Lesson 1, you just have to make sure you write them down in your notebook. We can say that secant squared x minus 1 is the same thing as tangent squared x. And now we have tangent squared x over sine squared x. Well, tangent is the same thing as sine over cosine. I'm just going to make sure I add in the squares there. And I can't actually divide my fractions. So I am going to multiply and make sure I take the reciprocal of that second fraction, though. And then we're going to see what cancels out. Well, the sine squared x is going to cancel from the top and the bottom, and we're left with 1 over cosine squared x. And that is another trig identity. We know that's equal to secant squared x. So after doing those couple rewrites there, we'll get that it matches with expression E, which is your secant squared x. here, let's try to rewrite each one. So cotangent, I know that is 1 over tangent. Or another way we can write cotangent is cosine over sine. And I actually prefer that one better. Cosecant is the same thing as 1 over sine. And we can't divide fractions, so let's rewrite this as a multiplication problem. Remember to take the reciprocal of your second fraction. And let's cancel out things from the top and the bottom. So all we're left with here is just cosine x then. For 53, let's perform the multiplication. All right, I do better if I actually write this problem out and then FOIL. So that's what I'm going to do. All right, let's start FOILing. So we get sine squared x. So sine x cosine x. So sine x cosine x again. Remember, multiplication is commutative, so it doesn't matter which order you actually write that in. Plus cosine squared x. All right, let's combine like terms. And since it's commutative, I'm going to rewrite my problem. So it's kind of nifty here. At the same time while I'm combining like terms. The reason I rewrote the problem is because I have a Pythagorean identity. Right here is the Pythagorean identity. And we know that sine squared x plus cosine squared x equals 1 using that Pythagorean identity. So if I replace that with 1, I end up with 1 plus 2 sine x cosine x. Right, the next one, perform the addition or subtraction. We need common denominators. So that means I need to multiply my first fraction by cosine. When I do that, I get cosine squared x. And I need to multiply my second fraction by 1 plus sine x. So I actually have to, I'd have 1 plus sine x times 1 plus sine x. So that's the same thing as saying it's squared. Okay. Cosine x. Okay. Let's FOIL. Let's see if we have to FOIL the numerator. Let's see what we can come up with there. I FOIL the numerator. I'm going to do this in my head. If you need to write it out and FOIL it, that's perfectly fine. Make sure you do so. 1 plus 2 sine x plus sine squared x. Now I can rewrite this. And again, what is cosine squared x plus sine squared x? That's the same thing as 1 using that Pythagorean identity. So replacing the highlighted portion with 1 and then combining like terms, I get 2 plus 2 sine x all over cosine x, 1 plus sine x. Let's pull out the like terms in the numerator. Since they both have a 2 in common, if I pull out the 2, I'm going to come over here now, just so I have more room. I'd have 1 plus sine x left. And notice, this is kind of nice now. Your 1 plus sine x is going to cancel out. So you're left with 2 over cosine x. And 2 over cosine x, remember that's the same as 2 times secant x. Because 1 over cosine is the same thing as secant.